Welcome to another episode of Practicing Chemistry Problems, where I hope to show you how you can tackle some organic chemistry problems without necessarily to memorize a whole lot of things. So again, just pause the video and attempt to do this problem on your own, and then you can play to see if you got it right or wrong. In this question, we asked to propose the synthesis of the following alkene from cyclohexanone as the only source of carbon. So how would I tackle this problem? Well, my first step would be to actually draw the starting material. So this is cyclohexanone, and we know that we need to go from here to this, and this is our only source of carbon. Okay, if I compare the starting material with the product, I can see I have two rings in the product, whereas I only have one ring in cyclohexanone. So there must be a carbon-carbon bond formation, and one of the easiest methods that I know I can do carbon-carbon bond formation or add another ring to this ring is probably through Grignard reagent. Now this might not end up working, but that would be my first guess, and that's where I would start. And before even bothering with the substrate and the product, I'm just going to remind myself about Grignard reaction. I highly suggest you do this too. It makes life easier. So I know for Grignard reagent, I need to have a carbonyl group, and let's just have a ketone so that it mimics the cyclohexanone that we're given. Then we're adding our Grignard reagent, which is an alkyl with magnesium bromide. And then I know for second step, I need to do an acidic workup. And this gives me an alcohol. That's why we do an acidic workup to protonate that oxygen. R prime, and let's just give this. Okay, so this comes from our Grignard reagent. Now if I compare this one to our product, I can see that I have an alcohol here, but in the product I have an alkene. I'm not going to worry too much about it because I know an easy way to convert alcohols to alkene, that's just through dehydration, so let's not worry too much about that. So my next step would be to start something similar to what I just drew, so having an OH group instead of that carbonyl group. So I know that I need one step here to go from alcohol to this double bond. So we're just going to skip that because I know I can do this through dehydration. We're going to start with the alcohol. It doesn't matter on which carbon we put the alcohol, so either this one or this one because they're both the same. Okay, now if I follow the same logic and of what I know about Grignard reagent, so let's just review it. So this is the central carbon, and I know that that carbon that was attached to carbonyl group now have an OH group, and we retain the same R groups. So if I look at this carbon here that had the OH group, it means that that OH group was actually originally a carbonyl group, and these two are the R groups or the ring. So let's just draw that. I know that must have been a ketone, which means this is my Grignard reagent. So this is why I would suggest that you draw on what you know about reactions, and then you can just follow along. So I know that my Grignard reagent would be something like this. Then acidic work. Okay. So now if I compare this to the substrate, so this is already cyclohexanone, and we're given cyclohexanone. Now because this is our only source of carbon, it means that we need to synthesize our Grignard reagent as well. So what would be your next step? How can I make this Grignard reagent starting from cyclohexanol? So again, just remind yourself how you usually make Grignard reagents. So if I think about it, I usually make Grignard reagents starting from alkyl halides. We're going to insert magnesium to give us our to give us our Grignard reagent. So if I do the same thing here, so we're now making this guy. It means that I must have started with bromocyclohexane, then I added magnesium. Now if I compare bromocyclohexane with my cyclohexanol, they're definitely not the same thing. So again, I need to do something. Well, what do you think is the next step? So if I think about it, I can't really think of any reaction that I know that would convert this ketone and add a bromine instead. What do I know? Like, what kind of reactions do I know that I can add bromine or substitute something with bromine? So for example, I know that I can add, oops. I know that I can add bromines to alkenes. So maybe through HBr or maybe through bromide, but then this adds two of them to the double bond, or if I use the water or alcohol, it adds one bromide and then one OH, so that's not necessarily useful for me. And then I don't even have this alkene, so again, cyclohexanol to alkene, not, I don't think that's really going to get me anywhere. How else can I add bromine? What other functional groups? So let's think about alcohols. I know that I can add alcohols, bromine to alcohols. I'm just drawing this as a secondary carbon to mimic what we have here. I know if I add something like HBr, it's going to protonate that alcohol. And what do you know about this guy, OH2 plus? I know that's a good leaving group because it can just leave as water. And that gives me a carbocation. Secondary carbocations are somewhat stable, not as stable as tertiary ones, but still okay. And then the Br minus is just going to be my nucleophile. Okay, so this is how I can add bromine. And this is through SN1 reaction. Now I can do something similar through SN2, but because I have a ring here, the nucleophile might have a harder problem because of steric to attack, so it should probably go through SN1. Now, what's one thing that you know about SN1s? What other reactions usually happen with SN1? So SN1 and E1 usually happens together. Though it really depends on the conditions, and this condition, if you're using bromine, is actually favored SN1. But if I don't want to get even a little bit of E1, so elimination reaction, what other methods do I know that I can convert alcohols to alkyl bromine? So another reaction that I can think of is PBr3. I don't really need to worry about elimination, and that's why I'm going to choose this one instead. Okay, so let's go back here. So if you start with alcohol plus PBr3, we're going to get our alkyl bromocyclohexane. And lastly, if I compare this alcohol to my ketone, that should be an easy one, because this is just an oxidation reaction. Through lithium aluminum hydride, for example. Okay, so now let's put everything together. I don't have a lot of space, so let me just delete this part. Okay, so we're starting with cyclohexanol. First step, oxidation. Next, we're substituting that OH with bromide. Then adding magnesium to give our Grignard reagent. Then reacting this with another cyclohexanol to give us this alcohol intermediate. And lastly, if we just hit this in the presence of acid, it's just a simple dehydration step. Okay, so suggestions or tips is to, if you think that there's a step, for example, like a Grignard reagent or alcohol, like SN1, SN2 reactions, just draw the overall big picture for yourself, so you can remind yourself what it actually does. I hope you guys found this video helpful. Let me know in the comment box if you guys like more of these practice problem series, and I'll definitely make more of these. Thank you.